So this structure will be called as a pyrene now. So as far as the pyrene is concerned, so pyrene is a carbon number 1, 2, 3, 4, and 5, and there's an oxide bridge. So look at this in the glucose molecule. So there is an oxide bridge is presented between the carbon number 1, uh, carbon number 1 and carbon number 5. The oxide bridge exists between these and getting this carbon number 6 out. So that means the carbon number 6 will be outside the ring. So this type of the structure is known as pyrene. So I again would like to say that this is formed by formation of a bond between the carbon number 1 and carbon number 5 by oxide bridge and subsequent conversion of the aldehyde into hemiacetal, or also called acetaldehyde, due to which the carbon number 1 and 5 they get linked and they form a ring-like structure which is called as a pyrene or pyrene, a pyrene-like structure. Pyrene is a chemical, and once the structure of the glucose resembles with the pyrene, this type of the glucose which is containing where the carbon number 1 will be linked to carbon number 5 by means of an oxide bridge. So this is an oxide bridge here, and we have here oxide bridge, and this oxide bridge here between the carbon number 1 and 5 pushing one carbon number 6 outside the ring. This type of the structure will be called as the glucopyranose. So this structure will be known as glucopyranose. So if we just want to draw now the structure, how the glucopyranose will look like. So the glucopyranose will look like this. And here we have how this. So now you have to follow here a rule. Those groups which are present here, just like I'll just mark them with a green. OH is present on the inner side of the ring, H on the inner side of the ring. So when you will just make a pyranose-like structure, what you will follow? You will follow an invert rule. So the groups will go here, and those groups which are present here, they will just go here, isn't it? So they will be just, so that means if we have a plane, this is our plane of our ring. Those which are present on the inner side, they will be drawn in the ring structure below the plane, and those which are present on outside of the oxide bridge, they'll move towards the inner side. So just like I would like to say here, suppose we have a glucose molecule here at the carbon number, this is the carbon number 1, carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. As far as the carbon number, this carbon number 2 is concerned now. So here you see that H is on inner side and OH is on. So here you see that OH is present on towards the oxide bridge. In the ring structure, I am just drawing it on the below the plane. So below the plane, see, this is using pencil. So this will be here, and this all the groups will be present here. So below the plane. So this will be, you can say, whereas the group which is here, that will be drawn here, and then. And look at the carbon number 3 now. H is present inner side, so it will go automatically outside, and OH on the inner side. Clear? So again, it will follow the same rule, just like here and here. And carbon number 4 is having OH on this side and H on this side. Here will be H, and the carbon number 6 will come out of the ring, and this will be carbon number 6, and here we call it as, this is called as the glucose molecule now. But depending upon now carbon number 1, the OH can be present now. So look at the first, I would like to tell you that as I already told you, the rule is that carbon number 4 will be taken for the D and L configuration. So if it is OH is present on the in the lower plane, so it will be called as, this structure will be called as D-glucopyranose. This will be D-glucopyranose. But depending upon the carbon number 1, which is called anomeric carbon now, carbon number 1 is known as anomeric carbon. Anomeric. And this anomeric carbon, on here we can have the OH either in this plane, we can have either in the plane where the OH is present on the same side of the OH which has been taken for the D and L configuration. So in carbon number 4, if the OH is present in the lower plane, it will be called as a D. If it is present in this plane, that it will be called as L-glucose and D-glucose. So there will be two kinds of the glucose, D-glucose and L-glucose. Suppose there will be D-glucose, and there will be another called as L-glucose. So in D-glucose, at carbon number 4, OH is on the right side in the lower plane, and here the OH is present on the above plane. This will be called as, you can understand, D and L configuration. But depending upon now the anomeric carbon, if OH is present on the, look at this thing. This is our carbon that we have to understand properly. This OH, if this OH is present on the same side of the D, so here I will mark it. It is the D. This is the hydroxyl for D, and this is the anomeric carbon. If it is present on the same side, this will be called as alpha D. Alpha. Pronounce it as alpha. This will be called as alpha D. Alpha D glucopyranose. This will be called alpha D glucopyranose. And if this OH is present on the opposite side, so let's have a look at the difference between the two structures. One is alpha D, another is the beta D. So one will just draw it here, so that we'll see clear differences between alpha D and beta D glucose forms. And it will be here another glucose molecule. Again, the same structure. So let me use a pencil to just make it shaded so that it will look like a and here, just again, I'm drawing here. So this is the H and OH for D and L configuration. This is H and OH for D and L configuration. So obviously, both of them are, this is this one and this one. Both of them are D glucose molecules. So then, I will just draw it here: CH2OH, CH2OH. See the difference? Here it will be H, here it will be H. Here it is OH, H, same. Here it will be OH, H, same. And at carbon number 3 is here. It's carbon number 4. It's carbon number 4 for D and L configuration. And then looking at the carbon number 2 again, so it will be again an H here at carbon number 2. And it will be OH here, and then we'll just see that if this H is present here, let me use another color. So if it is H here and it's OH here, so it's anomeric carbon number 1, and here it is anomeric carbon number 1. So see the difference here. Here it will be H and OH. So this will be carbon number 6, carbon number 6 here. So the carbon number 5, 4, 3, 2, and 1. So here we find the difference between the two. Look at this thing. Here, I'm just drawing here, see this OH and see this OH here. So this is the difference. Both of them are the D-glucopyranose molecules, but one of them is where the OH and this OH and this OH is on the same plane. This will be called as alpha D glucopyranose, and similarly this will be called as beta D glucopyranose. So these are the two structures. In this lecture we understood how it's possible to draw the Haworth projection of the glucose molecule and what's the alpha D-glucopyranose and beta D-glucopyranose. So depending upon the carbon number 1 and carbon number 1, we can have either alpha ionomer and beta ionomer. So alpha ionomer is that where OH is present on the same side of the D-hydroxyl, and beta ionomer is that where the OH on the carbon number 1 anomeric carbon is opposite, just like this. This is on opposite side. Here both of them are on the same side. So with this we finish today's lecture.